All right, today we are diving into one of the most powerful and honestly one of the most cleverly named techniques in all of computer science, dynamic programming. But let me start with a question. What if I told you that the secret to cracking some really tough problems wasn't about grinding harder, but about being, well, strategically lazy? It sounds a little backward, I know, but that is the beautiful, simple idea right at the heart of dynamic programming. So before we get into any of the official jargon or definitions, let's just lock in this one core principle. You can think of it as the cleverly lazy principle, and it's probably something you already do without even realizing it. I mean, think about it. If you spend an hour figuring out a really tough math problem, the next time you see it, you're not going to do all that work again from scratch, right? Of course not. You just look up the answer you already found. You're basically making a cheat sheet for your future self. That's it. That is the big idea. Do the work once, remember the answer, and never, ever do that same piece of work again. Okay, so now that you've got that cheat sheet idea stuck in your head, the formal definition is going to make a whole lot more sense. Let's actually look at what dynamic programming, or DP, as you'll hear it called, really is. So the textbook definition says it's a technique for solving problems by breaking them into smaller subproblems. Okay, that makes sense. And then, here's the magic part, storing the results to avoid recomputation. See? It's our cleverly lazy principle, just said in a fancier way. Don't redo work you've already done. Simple as that. Now, you can't just throw dynamic programming at any old problem. It's got to have two special properties. First, overlapping subproblems. This just means that as you're breaking down the big problem, you keep running into the same little mini problems over and over again. And second, optimal substructure. This is just a fancy way of saying that the best solution to the whole big puzzle is made up of the best solutions to all its little pieces. And you've got two main ways to get there. You can go top-down, which is often called memoization. That's where you start with the big goal and break it down, saving the answers to the small problems as you figure them out. Or you can go bottom-up, which is called tabulation. Here, you start by solving the absolute tiniest problems first and use those answers to build your way up to the final solution. Two different paths, same destination. Theory is one thing, but let's make this feel real. The absolute best way to get a feel for DP is with a classic problem that's kind of like a fun little puzzle, the knapsack dilemma. So just imagine this for a second. You're an adventurer, and you're about to go on some epic quest. You've got your backpack, your knapsack, and in front of you is a whole pile of cool treasure and useful items. But of course, there are rules. Every single item has two things: a value, like how much gold it's worth, and a weight. The catch is, your knapsack can only hold a certain total weight. Let's call it W. And, this is important, you can't break things. It's all or nothing for each item. So here is the million-dollar question. How do you choose which items to pack to get the absolute maximum, the most possible value, without your bag getting too heavy? I mean, you could try every single combination, but that could literally take forever. There's gotta be a smarter way, right? And here is where it all clicks. The dynamic programming solution breaks this huge problem down into a super simple choice for each item. As you look at an item, you only have two options. You either take it and put it in the bag, or you leave it behind. That's the small, repeatable decision we need to make. So what dynamic programming does is it builds out that cheat sheet we talked about, a table. This table keeps track of the best possible value you can have for every single weight capacity up to your bag's limit. It systematically builds the perfect answer by making that optimal little take-it-or-leave-it decision step by step for every item. So that's the knapsack problem. But trust me, this technique is not just for figuring out what to pack. Let's take a quick look at where else this building block strategy shows up. This whole idea of finding the best solution to small parts to construct the best final answer is incredibly powerful and versatile. You see it in things like calculating stock options, in DNA sequencing, and in another classic computer science problem. Take something called an optimal binary search tree. Just think about organizing a huge library. You wouldn't put the most popular books way in the back, right? You'd put them up front where they're easy to find. Dynamic programming helps a computer do exactly that with data. It figures out the most efficient way to structure everything so that the most frequently accessed information is found the fastest. It's the same principle, building the best overall structure from the best small choices. Okay, so as we start to wrap this up, I really want you to stop thinking of dynamic programming as some intimidating algorithm. Think of it as a superpower for solving problems in a really smart, efficient way. So if you only remember 3 things from our time today, make it these. 1.
Break your big, scary problems into smaller, simpler ones. 2. Store the answers to those small problems. Make your cheat sheet. And 3. Use those saved answers to build up to the final solution without ever wasting time redoing work.
Now look, this has been a really quick, high-level tour just to give you the core idea, the intuition behind it. We purposefully skipped the heavy formulas and the code, but if you're feeling ready for that, if you want to see how this actually works under the hood, I've put all the full source notes and even some code examples for you right in the comments below. And I'll leave you with one last thought. This idea isn't just for computers. Think about a big goal you have in your life. Maybe it's learning a new skill or finishing a huge project. Where could you apply this cleverly lazy principle of breaking it down, solving the small parts first, and building your way to an awesome final result? Thanks so much for tuning in.